Replace your print servers with a secure cloud solution that scales with you. You'll automate print management, get scalability and flexibility, as well as complete control with visibility into all your print processes. Start a free 30-day trial by going to printerlogic.com/packet pushers.
Hello, I'm Jonna Till Johnson, CEO of Nemertes, here with my co-host John Burke, CTO of Nemertes, and you're listening to Heavy Strategy, the show that tries to ask the right questions, not give the right answers. And we're super psyched to be here today with Russ White, who is currently the senior architect at Akamai, who's also worked at Cisco and Juniper. He's also written more books and gotten more patents than he actually knows how many there are. Welcome, Russ.
Well, thanks. Yeah, it's kind of crazy, isn't it? But I actually don't know how many books I've written.
I think that is pretty crazy. And also on the patents, I think you said you were up to number 50 if the most current one is accepted, right?
Yeah, I think it's 50 now. Yeah.
Okay.
I think with the latest file.
And they are really interesting topics, which unfortunately we can't talk about for the show, but stay tuned for those because patents do become public knowledge once they're granted. So you can go dig into those. I guess the biggest thing is that you've been in the networking field, I don't want to say since its inception, but kind of since its inception.
Okay. I started working on computer networks in probably the late 80s.
That's about right. I started looking at all this stuff in the early 90s. So I was late 80s as well.
Yeah,
I think my first IETFs were in the 80s. So,
but I mean, History of Science guy says this stuff's been going since the 70s. Just,
Yeah. Oh, yeah, of course.
Not for most people.
Yeah, of course. Yeah. Right. Yeah. I mean, I started working on Token Bus and then somebody asked me the other day, or somebody asked on X the other day, so what's the oldest operating system you worked on?
We know this one.
Yeah. I think it's probably Digital Research CPM.
We think so too, because we were talking about operating systems with you earlier, and there's a plaque. Those of you who are listening can't see it, but there's the plaque on the wall, which is actually the original discs from CPM, which is incredible.
I do think that's the earliest version I've worked on.
And that definitely have the legacy chops there. So
that's not true because I actually worked on a Cocoa. I had a Cocoa too, and I guess that's a different operating system. So I don't know. Anyway,
that one I'm not even familiar with. So
no.
Okay, well, John, I know you had some questions. Some questions to start Russ off, and then we'll see where this goes.
Yeah.
Well, we had discussed talking about protocols since we're all networking folks in one way or another, and why some succeed and why some fail, and maybe some that we wish had failed and are still out there thriving. So. We framed this negatively, why protocols fail, but I'm actually kind of interested in your thoughts on why some protocols really succeed. You and I and Jonna were all around before IP was guaranteed success, before Ethernet was guaranteed of success. Why do things succeed like they did?
Yeah, it's interesting. Yeah, I mean, I've worked on Token Bus and ArcNet. And by the way, ArcNet was really horrible. Just for those who don't know.
It was, yes.
It was really bad. We had this one site, every time it rained and lightning, at least half the ArcNet adapters would go away. You're like, maybe you don't have good electrical protection in your adapters. I don't know. It could just be me. But, that's a thing. Yeah, so I actually do think that protocols that succeed tend to be those that not only fill a niche, but are designed to be flexible without adding so much complexity or have the ability to compartmentalize their complexity. So for instance, in the case of BGP is actually a fairly complex protocol, but it's able to compartmentalize the complexity so that, you have different address families. And there's actually other compartmentalization techniques in BGP that I wish we would use. I don't know if you know this, but in BGP, you don't just have address families. You can actually negotiate how many different kinds of data you're going to carry over the BGP session.
No, I did not know that actually.
And nobody uses it. Like there's only one kind of information ever carried over a BGP session. And then what we did was we said, okay, we'll do different address families instead. And often I look at BGP and I think, really, that should be a negotiated kind of information that should not be an address family. Like that address family is really just something completely different. It's not even an address family.
Yeah. Because then you can do policy routing and everything else. Well, actually, speaking of BGP, I'd love your perspective on this because over at Network Break, we sort of repeatedly talk about the relatively recent thoughts. The U.S. government suddenly said, "Oh, we really need secure BGP, and everybody needs to implement secure BGP." And I remember thinking, good God, there was an RFC for that from like 15, 20 years ago, which there was. It has now been obviated by a new RFC. And it seems like I don't understand why the government isn't simply saying, just go implement it, people. It seems to have this desire to create its own definition of what secure BGP is. And we've already done it twice. Like, can't we just implement the current secure BGP and leave it at that?
No.
Okay. Explain why. This is great.
So this is one of those cases where, in my opinion, anyway, and I've been in this fight since, I don't know, the mid 90s. I've been in the secure BGP fight. I'm one of the people who helped develop SOBGP and then pass state vectors, and had a lot of talk with people about BGP. People probably don't even know what these are because they're old, technologies that nobody ever implemented. And if you look at ASPA, it's roughly or loosely based on SOBGP. That's actually the origin story of that. So I think this is one of those situations where the complexity becomes so great and you actually end up opening new attack surfaces that are greater than the attack surfaces you are solving, than you are plugging, right? That's what BGPsec feels like to me. As I always look at it, I'm like, so you're telling me that not only do my routers have to have all this additional data, I can't pack anything, so I've reduced a lot of the efficiency in carrying BGP stuff, but once I've advertised something with a signed update, there's no way for me to remove that without rolling my key. And now if I am somebody like Akamai, which is where I work, right?
Right.
We have thousands of BGP speakers, and we have thousands of prefixes that we advertise for thousands of different people. And you're going to tell me that I have to roll the key to fully withdraw something. And the answer is no.
No.
That's not going to happen. Right?
Not happening.
Yeah. Or my other option is I can put a timer in it. Ooh, that's brilliant. Let's put a timer in our BGP updates. Wait, set the timer. So there's 1.2 million routes, thereabouts, in the DFC, something like that. It may be higher, it may be lower. I haven't looked. I put a 24-hour timer on it, which means I'm going to get 1.2 million updates every 24 hours. Like, just the math doesn't work. It's just crazy. And so this is one of those examples of where, people came up with ideas, things happen, but for various political and technical reasons, it's just failed to deploy because people just are like, no. Now,
I would say it's not really political, though, from what you've said. Essentially, what you're saying is the current IETF spec, which I can't remember the RFC number, and I should know it, is effectively too complex to be successful, is what I'm hearing. Okay, so how do we fix it?
So that there's another piece of this, right, which is RPKI and ROAs, and they are quite complex, and they're not as how should I put it? They're not as we're going to go fix all the problems, right? They're very narrow in their focus of what they're trying to solve. And these are deploying. And that's actually what's in the government thing right now is you need to go deploy RPKI and ROA. And I don't think anybody really disagrees with RPKI and ROAs. I think what people are struggling with is going beyond that and figuring out what you do next. Because, as I often say, BGP, really most of the BGP stuff that goes on, configuring a BGP session is the easy part. That's the part that's the easy thing to do compared to finding the right person at the other company you want to peer with, negotiating a contract, looking at where the physical cables go, grooming the circuits. configuring BGP is like, oh, you could almost forget it. It's almost like a footnote in the whole peering ecosystem. Like, oh, we got to configure BGP. Yeah, I would have thought of that.
Yeah, right.
So, yeah. So it's a very complex ecosystem. And this is one of those instances of a protocol that has largely failed to this point.
And when you say largely failed, you mean BGP sec, not BGP.
Right, not BGP. BGP
Yes.
sec has largely failed. Yeah, right. And there are alternatives, not necessarily, I mean, RPKI ROA is part of BGP sec, is one piece of it from the original work. And then, like I said, there's this other thing, ASPA, which I'm fairly interested in. I haven't spent a lot of time in the drafts and stuff, but I basically know how it works because I've talked to people and read through the drafts a bit. And beyond that, it would be fun to resurrect path state vectors and other solutions that are out there and potentially think about how we solve these problems. But yeah, I don't know. I mean, part of it to me is always when I look at these things, protocols fail in part and succeed in part because they look beyond what the current problem is.
That's an interesting statement, but I would push back on that slightly because what I've seen is protocols succeed when they look beyond the current problem with the right level of analysis. Like if they try to solve a problem that they foresee without fully understanding it, they fail, which is kind of where I think BGP sec falls into. Right. But at the same time, let's take a love to hate protocol IPv6. They kind of kicked the can down the road with IPv6 because they basically said, here, we're just going to give you a giant address space and you will figure out how to use it to make it work because we're solving the immediate problem. We need more addresses and we're not even going to put any meaningful structure on that address space because that thought will come later, and it never did.
Well, actually, I think that IPv6 ran in both directions at the same time. And that's, and that's part of the struggle of getting it deployed is I was involved again in some of the early, and I can very specifically remember a lot of weird conversations on IPv6 mailing lists about this stuff. It was like, okay, we're not just going to give you bigger address space. We're going to give you extensible headers in a way that v4 couldn't. Okay, well, that's great. And that's awesome. And it's not a bad thing to have that. But the early warnings about Silicon and not being able to process these headers, hop by hop headers, did actually slow down the deployment of v6 for some period of time.
Not something I'd really thought about. Yeah.
Because you just can't do it. And so people were like, chips vendors were like, I'm not supporting all those crazy hop by hop headers. You're crazy. I can't keep my Silicon up, to speed with every new hop by hop header. So part of what slowed down IPv6 deployment was that kind of thing where they kind of went outside of where they should have been. In many ways, they would have been better off just to say, here's a larger address space on the current IPv4. Well, by the way, there's things we don't use an IPv4 header anymore. So let's clear those out. Mm-hmm. Let's get rid of that garbage. And let's give you extension headers, but we won't do it hop by hop because we understand the Silicon problem. And then just let people figure things out like SRv6 and stuff like that. Just go do stuff. They would have been better off in some sense to make it extensible than to try to solve. And another problem they tried to solve early on in v6 was they tried to solve network address translation.
Yes, they did. And it was like, why are you solving this? Network address translation exists. There is a solution. Let's move on. Come on.
Yeah, exactly. And it became this huge, almost like religious argument. Horrible argument over, it's network address translation is not security.
Right. You can't do it at scale. Yes, you can.
Yes,
and it's a terrible idea. No, it's not. It's a kludge, but okay. Yeah, elegance is what elegance does. Sometimes you use kludges. Exactly. Yes.
So it sounds like it's not so much building your protocol to try and solve all the problems you can see, because you can see problems that you have no idea how to solve yet.
Right. Yes.
Building it to solve the problem it's supposed to solve, and not forestalling the ability to solve those problems down the line. like
That's
doing putting as little in beyond what you need, so that there's room to add things you can't figure out yet that you need.
Exactly. Yeah.
Exactly.
And John, I like that, because my biggest issue with V6 has always been what we had not done yet was revisit routing to think about how we could make it much more scalable, and in particular to support multi-homing, which we knew was coming. And to my mind, that's dead simple as a problem to have. And what the V6 contingent argued forever was, we don't need multi-homing, or we don't need to solve that right now. We'll just set up a giant address space and it will solve all future evils. But
or we will solve multi-homing via renumbering.
Yeah. Oh.
Right.
No, you won't. Yeah. But it was weird, because and as we're mapping the actual evolution of V6 to what you just said, John, yes, they were trying to solve a problem that already had a solution, NAT, and not trying to solve the bigger problem that was looming, which was multi-homing and more broadly routing. And I do remember that the fundamental almost political argument in the IETF at the time was whether we did routing first and then V6, or V6 first and then routing. And the problem was, and I remember this very vividly, was that people were terrified that we'd run out of address space by the year 2000 and the IETF would look bad. And that was it. That was actually the motivating factor, because I remember Fred Baker was the chair of the IETF at the time, and he went around trying to ask everybody, like, the people on the routing contingent, guys, do you think you will have a routing solution in time for us to not look like idiots? and the answer was probably not. But there was this mindset that looking like idiots was not our problem, which I would say is in fact the correct mindset, right?
Yeah.
You can't create a good protocol or a good design if you're defensively trying to not look stupid.
Yeah. Yeah. And that is just such a classic example. Like for me, NAT has always been network address translation. And by the way, it's not even network address translation is the problem. It's port address translation, but we just use the terms interchangeably. And the problem for me with port address translation has always been stop embedding IP addresses in your protocol.
Right.
Like the IP address identifies an interface. It is not a host address. Stop calling it a host. I mean, now we call it a host address. It's not a host address.
Identity is not location.
Yes,
location
exactly.
is not identity.
Yes. Exactly. and yet we do this. We're like, oh, but if I put the IP address in there, I'll know who I'm talking to. No, you won't.
You'll know where they are at this exact moment.
That's right. Yeah. That's
well, it's funny that you mention that, because I saw that just the other day, and there was an article in the paper about some guy that had been doing heinous cyberbullying on Discord. And a whole lot of people in the comments section were like, wow, can't they just identify him by his IP address? And it was just like, everybody thinks they know what they're talking about. I'm like, dudes, you just have no conception. Just go away. Don't post.
It's because you're watching too many police procedurals, right? I mean, the most fun one to me is when I was watching this police procedural and they were like, well, we know our suspect is from Miami. And over here, we can see that they have a Miami IP address. So therefore, really, you could see that.
Well, now that you brought that up, I've got to bring this up. I can't even remember the name of the movie, and it was around the late 80s or early 90s. Sylvester Stallone was a guy who had been like frozen in time and cryogenic.
Demolition Man.
Yes. He pops out and he's driving with a woman cop going somewhere to do something, and she gets all this information on a display on her screen and goes, how do you guys do that? And she goes, fiber optics. And I'm like,
she's driving.
Yeah. She's driving. I'm like, I can envision the long fiber tail waving in the wind. I was like, oh God, that was.
And that was Sandra Bullock, by the way.
Yes,
it was.
Movies.
So yeah. I think the classic example to me of complexity, and I don't want to say that OSPF has failed. Lots of people use OSPF.
Yeah, right.
But the classic example to me of just solving the problem at hand and leaving things open for the future is OSPF versus IS-to-IS. And I don't know if you remember this or not, but way back in the day when the IETF was standardizing OSPF, they actually printed t-shirts that said IS minus IS equals 0.
Oh, no, I don't remember that, but I do remember the war.
Yeah, that was a huge war. And it was so bad, and it was so political and everything. And yet in the end, how many versions of OSPF are there? Like, how many different ways? So you have OSPF v2, then you have OSPF v6, v3 for v6. And then you have, okay, well now I've decided I don't really want to run two protocols. So I'm going to backport v4 into OSPF v3 so it can run with OSPF v6. And then, by the way, we really don't like fixing fields anymore. So now we're going to have a completely new set of TLV based data in OSPF. And you're like, okay, just stop.
Just stop, okay, right? Just stop. Can we just hammer on and bolt on and hammer on and nail on?
Yeah, just stop, right? Whereas ISIS is ISIS. I mean, it's been the same protocol for the last 30 years. Like it just doesn't really change. And you just keep adding stuff to it by you just add a new TLV. Oh, we don't care that. Just add a new TLV. Oh, we're out of TLV space. Oh, we'll just add a different TLV and, make it where you have extended TLV space. Oh, that's not a problem. It's like, although there are some really funny things in ISIS, like we don't carry the MTU size.
Mm-hmm.
Just send packets max MTU. And like, if the packet doesn't get there, form an adjacency. Wow, that was hard.
Streamline your IT infrastructure by switching to a cloud-native print solution. You'll reduce infrastructure by eliminating print servers, get front-end and back-end print management. You'll be bridging the gap between automation, document management, and print. You'll secure your data end-to-end with native integrations and enjoy a zero-trust-enabled environment. Start a free 30-day trial by going to printerlogic.com/packet pushers. Oh, it also integrates easily with EMR and ERP solutions. Plus, a simplified scanning solution is included. You can automate capabilities, create no-code forms and workflows in the same admin account, have full visibility, and reduce print tickets by 90%. Start that free 30-day trial by going to printerlogic.com/packet pushers.
Well, and that's the other thing. Sometimes I think in developing any kind of protocol, you want to think about like, what do you really not need? And it's almost like a game of Jenga where you start pulling all the pieces and see if it still stands. But I want to kind of circle around to something because seeing as this is heavy strategy, some folks may be listening to this going, yeah, right on. And some folks may be going, I don't know, this is just a garble of a bunch of words. And I don't know, ISIS, OSPF, BGP.
Yeah.
But I think one of the reasons we wanted to talk about this is that philosophically, when you're developing an architecture, when you're developing any form of defined interface, these are things you want to think about. How flexible is it? Am I really solving the problem I need to solve while leaving room to solve future problems? Or am I attempting to solve a future problem that I don't fully understand and I'm just sort of throwing complexity at in the hopes that somebody down the road is going to figure out how to apply that complexity?
Yeah. This is definitely an architectural level problem that we face all the time. It's crazy how often I run into this. Let's use a GRE tunnel here. Okay, is that going to last? Is that like durable? Is that really going to fix this? Let's use this over here. A classic is everybody says, well, I can future-proof my network by building with large chassis boxes, and I can just leave half the slots open because I never know what those slots might need.
Right. I have done that. Yes.
Yes, right. Oh, I've done it too, right? And you're like, well, is that really viable? Is that really the right way to do things? Or am I better off to use a bunch of little boxes that can individually be replaced rather than that one big chassis box? Like the whole idea of future proofing by building lots of extra port space is like, yeah, I'm not really sure that works. Maybe build your network with the kind of topologies that allow you to spread things out and to scale out instead of up, instead of doing it that way. And that comes back, just straight up to design. How am I designing this? What's my future goal? And even things like, what happens if the business in this area shrinks and I need to actually make the network smaller?
Well, and as you're talking, it occurs to me that a decent fundamental principle to pull out of all of this is something that says, get it to work first and optimize it later. And I've always loved the IETF's motto of rough consensus and running code. Right. Make it work. do your proof of concept, prove that it can work and that it can solve the problem at hand, and then worry about, doing it in the optimal way. So for example, instead of getting a couple of half-empty, really big chassis, wait until you arrive at that point where you have lots and lots of little boxes, and then do an optimization step where you turn those all into boards in your chassis. And the problem is that usually works, except when it doesn't.
Yeah, right. Right. Yeah, there are cases when you have to realize that this is going to you can see it coming, that this is going to get big and you need to do something. But the other thing I would add to that is sometimes you don't even need to optimize.
Right.
Right. I mean, optimization is a trade-off. And this is something we always fail to do. We never think about trade-offs. We always think, I'm going to optimize for this and everything's going to be great. Yeah, not necessarily. You can over-optimize, and every bit of local optimization you do causes the global view to be de-optimized. And every bit of global optimization you do causes local de-optimization. I mean, it's just the way things work. I'm sorry. You can try to break the laws of physics all you want to, but you're not going to. There's just like optimization. You either have to add state to get to optimization, or you have to add new places where you're doing aggregation, what I call interaction surfaces. And then, like I said, every time you do a local optimization, I'm going to make this campus network work so well. It's going to be so great, this campus network. And then you bend the entire core around making that campus network work really great. Like, really? Was that I don't know that was the right solution.
Yeah.
Who was it? Nicholas Wirth, right? The guy who invented Pascal and Modula 2. Didn't he say premature optimization is the root of all evil?
Yeah.
Ooh,
yeah.
I love that.
That's a definite.
Yeah. Yeah. No. Well, and I think the other thing that I think is really interesting is this notion of state and adding state and reducing state, because John, I know you've done a lot of design outside of networking. I know for those of us in networking, you're always thinking about state. Do you guys do that outside of networking when you're developing, I don't know, architecting a database or something like that?
Yes. Yeah. And there again, optimizing at the wrong place and in the wrong time can just make life so much more difficult down the road. And you expend a lot of effort doing it that could have been spent better actually doing the work you're doing with the database, for example.
Yeah.
Well, and what I'm getting at with state is this whole notion that, and whenever I do a design, I'm always looking at what are the possible states I could end up with. And Russ, when you said you're adding state, that adds complexity in a dimension that people don't usually think about, because people will say, well, it's not complex. It's only got, 4 bits over here and a port over there. And it's perfectly not complex, but complexity comes from the number of possible states that can result.
Right.
And that's something, I guess, as a design principle, I don't see a lot of people thinking about.
Yeah. Well, the database example is perfect, right?
Mm-hmm.
And now, of course, we have this in routing. But routing is what? Routing is a distributed database with a defined set of algorithms or heuristics. Because really, Dijkstra is not we call it an algorithm, but it's a heuristic. But anyway, so think about if you're going to build a database and you're going to say, well, somebody may have more than one address. So I'm going to create 2 different tables, one for addresses and one for names. Okay, that's perfectly rational, but now you need a way to connect them. Mm-hmm. And when the person's name goes away, because you've taken their name, you need a way to filter out and clear out all their addresses. So there's connectivity, there's connective tissue there that has to take place. That is state. And the more you change the names and the addresses, the faster the velocity of state is. And so therefore you end up with this high velocity, high volumes of state. And that's where you get into trouble. And feedback loops. That's the other thing that people don't think very much about is feedback loops. But yeah. And so I think the database example does come into play. I think these are all real things.
Well, and the reason I raised it is because I don't see a lot of people using things like layers of abstraction and state tend to be network specific. And when you raise them to non-network architects and engineers, they kind of give you a, why should I think about that look? And I think there's something, I guess, because when you're visualizing a network, it's a constantly changing dynamic thing. for us, it's sort of innate to think about state and also layers of abstraction because we have we created the OSI 7-layer model, yay us. But which, by the way, hasn't been replicated anywhere else for any good reason. And I have a question on that. But it just is interesting that people don't think about state as a marker of complexity.
Yeah. Well, and we do this in applications, right? And this is the thing, right? This is a directly transferable skill that the network engineer or architect has that should be something you're feeding into the business. Mm-hmm. Are you actually thinking, speaking of like architecture and heavy strategy stuff, right?
Right.
Are you as a business thinking about where your abstractions are, how those things work? And by the way, there's also Joel Spolsky on software, the Joel on software blog, all non-trivial abstractions leak.
Mm-hmm.
And so, right. So not only do you need to think about where you abstract, you need to think about where could this abstraction leak?
Mm-hmm.
What under what circumstances does this abstraction leak? And what impact does that have? I mean, going down to basics, like if I aggregate my routes here, then I'm going to de-optimize the routing path there. Or if I aggregate here and the route on which I'm pulling the aggregated metric changes, I change the metric. So therefore my aggregation's actually not doing anything. It's not actually reducing state. I'm just aggregating because, hey, it looks good, right? These are like weird little side things. And again, it hits databases, it hits data center design, it hits core design. All of these things, they all face these same problems.
Well, and it's when you say that they all face these same problems, I think you're absolutely right. And one of the challenges that we have is for IT, I think we're not used to dealing with these problems because in some sense, we're not developing the stuff, we're just hooking together stuff. Yeah. But when you hook it together, you're developing something, you're developing the thing you're building. And you can even say, oh, I'm just hooking together a bunch of clouds. Well, you're still hooking together stuff and you still have to think about all of this that way.
Yeah. And in your interactions with the developers who are developing the code or deploying applications, it's exactly the same thing. We just don't push back. We just say, oh, give us your requirements and we'll do that.
Yeah.
Well, no, that's not the right answer. The right answer is what are you trying to get done? Don't tell me how to do it. Tell me what you're trying to get done. And let's work together on solving the problem or getting the goal done. This is part of what's happened with the waterfall idea in software development is I'm going to gather all my requirements and I'm going to go tell all my coding teams to go do
exactly what they do. Yeah.
Right. And that's just not the way it works. No, you need to all right, look, what's the common goal? What are we trying to get done here? And now let's brainstorm different ways to do it. Right.
And we don't do that. It's interesting because in the military, there's a concept called mission command, which is exactly that. It's a horrible, horrible name, but it's essentially what it does is look at the layers of abstraction, so to speak, of the mission. The mission may ultimately be win this war, or ideally, as somebody in the military was telling me yesterday, that we don't have a war at all. Right. But win this war, which means win this battle, which means take this hill. Right. And the challenge is you want to give the people who are charted with the mission of take this hill an understanding of where the hill fits in the scheme of the battle, in the scheme of the war, so that if they have to make decisions on the fly, they're making them aligned with the mission command. And this is something we actually teach our clients through adaptive leadership training. We talk about how that applies in business, where it's you have to be carrying in your head the knowledge that your mission is part of a bigger mission and that bigger mission is part of a bigger mission. And you want to make sure that any decisions you make, any changes you make on the fly are aligned with that bigger mission. But what happens, and the hard part of that, is for the programmer or the soldier on the field, the main thing that changes with mission command is that person needs to ask a lot of questions and the superiors need to be very comfortable answering them. And that's where you get the politics, because what happens is the person who told you to write, gave you the requirements, doesn't really know what the requirements are for. So he or she gets really nervous when the programmer says, okay, but what are you trying to do with this code? They don't know, and they don't want to admit that they don't know. So they lie, obfuscate, yell at you. And then that information never makes it all the way down.
Or they tell you can't know.
Right. Well, that's true too. Yes, you can't know because only the generals get to know this.
That's right. Only so and so. But I think the other side of that is to realize that the abstraction runs both directions. You might think, sitting in your little office or in your field office looking at this map, that the best way to take that hill is to approach it from the east.
Mm-hmm.
But the person standing in the field might look at the hill and go,
The east side is just a big mud flat.
Yeah, right. Exactly.
And a lot of what we do with our workshops on this kind of leadership is exactly that. We walk through people through this kind of thing, and we give them decisions to make that can be made more or less effectively with the right information, and sort of train them that it's their responsibility to get the information. Yeah. And that is the hard part, because it's one thing when everyone involved has bought into the idea and will give you the information if you ask. It's just different. We keep finding it again and again in established organizations that they want to control the information flow because information is power.
Yeah.
And that mindset is antithetical to the possibility of mission command. Yeah. And it's one of the reasons that large programming efforts fail, because the information you're not allowed to have that.
And it's also micromanagement. Like, right. You've got to be able to say, okay, what we need to get to is we need an application that goes to all of our insurance agents that allow them to do X.
Right.
That's the business decision. Then you need to let the coders or the programmers work with the network people to figure out how to divide the set of problems that need to be solved effectively. We don't do that. The business people say, we want this application that's going to make all the insurance agents do that. Okay, great. We want it to look like this. This is the UI, and this is how we want it implemented. We want it implemented using these tools for these reasons. Then the programmers come to the network people and say, we need a layer 2 VPN. We need not even a layer 2. We need layer 2 connectivity between every device in our network, because that's the way we've programmed this. And like, all of that is broken. Every step of that is broken. Right.
Yep. And honestly, I think, we've wandered far afield from why protocols don't work or do work. But I think this is exactly the direction that we wanted to go in. That, kind of boiling down, I think it's safe to say that things like IP and, to a lesser extent, Ethernet work as well as they have, because the people involved in generating them understood the big problem, understood the mission, had nobody to get in the way to tell them what the mission was or wasn't, and try to micromanage them. And also, in my head, at least, I will staunchly insist that this is the reason this emphasis on rough consensus and running code, which is just the 1980s version of agile programming and, getting minimum, what do they call it?
Minimum viable product.
Exactly, MVP. It basically says, let's see if we can get it done and hold off on the optimization for later. And, I think those are timeless truths that probably any architect or strategist should keep in mind.
Yeah. Well, I mean, going back to OSPF and ISIS, why is OSPF built the way it is? Because they optimize for bits on the wire on day one in a time when processing was expensive and bandwidth was expensive. And ISIS said, yeah, processing is expensive. Yeah, the wire is expensive, but that's going to change. And what's not going to change is the complexity of carrying data. So let's just carry the data in a suboptimal way for right now. And in 20 years, the suboptimality in this particular situation really won't matter. We're going to grow past it. And the result was a very complex protocol. And again, I'm not saying that OSPF, lots of people use it. I don't hate it as a protocol, etc. I'm just using it as an example of where somebody injected extra complexity in the beginning to create flexibility that allowed less complexity later, versus somebody who built very deep focused on simplicity in the beginning and optimization in the beginning and ended up with a lot of complexity later, right? It's just two different stories. and they solve the same problem by and large, right?
Yep. Yeah, no, that's a good way to think about it. And hard as it is to believe, we are actually coming to the end of this episode.
And you didn't ask me about models.
We have, that'll have to be a next episode, I guess.
I have to jump in with a correction. We incorrectly attributed that quote on optimization to Nicholas Wirth, but it was in fact Donald Knuth, our good friend and pal.
Oh, good. Yeah, see,
there we go.
I don't know who makes these quotes.
Yeah, exactly. But premature optimization is the root of all evil. I think probably does belong on an IT T-shirt, John.
Yeah.
Along with your rock is not my rock, but that's a whole other story. And we have a whole line, hypothetical, mythical line of IT T-shirts that are, bad IT. So
yes. Good.
So Russ, is there anything else you wanted to add before we wrap up? Any other final thoughts other than that we have to talk about models next time?
Yeah, no, that's fine. I'll come on any old time.
And Russ, if people want to reach you, where can they find you?
So the best place to start would be rule11.tech.
Rule11.tech.
Yes, RFC 1925, Rule 11. And so I don't really do a lot of direct work there. I used to do a lot more writing there than I do right now. But I do post everything I post to Packet Pushers every time I'm on a podcast, every episode of The Hedge, anything I post to Rule 11 Academy, anything I'm doing at Pearson, that all ends up being posted at that rule11.tech as a blog so that you can that's a good starting point.
Okay.
And that's Rule 11.
Yes, rule11.tech. Yes.
Okay, great. And as always, for listeners, if you've got feedback or follow-up for us, if you want to hear more or less, have questions for Russ, please send us a message at packetpushers.net/FU. That's follow-up. Don't think what you're thinking. It's follow-up. We'd love to hear from you about your own experiences, your own thoughts, and if you take issues with any of the principles we've pulled out on this episode today. You'll also find there the Network Break podcast, which helps you stay current on the latest tech news and what it means, and a whole lot more. If you'd like to reach me or John, you can reach us at nemertes.com. That's N like Nancy, E-M like Mary, E-R-T-E-S.com, nemertes.com. And we look forward to hearing from you.